Welcome to Shanti-Peace for Mathematics. This video gives you review about the differential equation. So the first question arises in our mind. What does it mean of a differential equation? An equation which involves the derivative of dependent variable with respect to the independent variables is said to be differential equation. For example, if I have a y which is a function of one variable, then we can say that y is a dependent variable and x is an independent variable. And then any equation which involves a derivative of y with respect to x, it's called the differential equation. For example, I can write down dy by dx is equal to 0. Or I can write down the square y by dx square plus y equal to 0. Or I may write down the cube y by dx cube plus dy by dx whole square is equal to y into sine square x. If you have a function z which is a function of two variable or more than two variable, let's say it is a function of x and y, then here it is a z is a dependent variable and x and y are the independent variable. Partial derivative of z with respect to x and partial derivative of z with respect to y are involved. That equation it's also called the differential equation. For example, del z by del x is equal to c into del z by del x square, or I can say del square z by del x square plus del square z by del y square equal to 0. So these are some examples of differential equation. There is a classification of this differential equation is there. So I may write down here is a differential equation. So now you know what you mean by differential equation properly. Now there is a two classification of this differential equation is there. One of them is the ordinary differential equation. The another one is the partial differential equation. Now what do you mean by ordinary differential equation? And differential equation which involves all the derivatives which refer to a single independent variable is said to be ordinary differential equation. For example, we have seen that dy by dx plus y equal to 0, or you can say this cube y by dx cube plus x into y equal to 0. So these are some examples of ordinary differential equation. What do you mean by partial differential equation? A differential equation which all the derivative refers to a two or more independent variable have been involved. It's called the partial differential equation. For example, we already seen that which involves the partial derivative, which is del z by del x is equal to c square del z del square z by del y square. Or I can say a Laplace equation which is del square z by del x square plus del square z by del y square equal to 0. So that is a classification of differential equation is there. In this course, we are going to focus on ordinary differential equation. And in that, we will study how to solve this type of differential equation, what are the different techniques to deal with the ordinary differential equation. So the first things that we will need to discuss is the order of the differential equation. So what does it mean of the order of the differential equation? The order of the highest derivative appearing in the differential equation is said to be order of the differential equation. So I will write down the same thing here again. The order of the highest derivative appearing in the differential equation is said to be order of the differential equation. The next definition is the degree of the differential equation. The degree of the differential equation is the highest degree, or you can say it is a power. So highest power of the highest order derivative when the derivative are free from the radicals. What do you mean by radicals? Means it is a root and a function. Okay, then it is called the degree of, that is called the degree of the differential equation. So I may write down that is also again here. So the degree of the differential equation is the highest degree, or I can say power of the highest order derivative when derivatives are free from radicals, or I can say roots and from fractions. So it is free from radicals, fraction. So let us say lots of examples regarding this, how to calculate the order and the degree of differential equation. So first example, I may write down dy by dx is equal to y. So order, O refers to order, D refers to a degree, or I can just make a column here. So I may write down here order and degree, and we make one table for this differential equation. This is the first differential equation that I have written here. So what is the order for this differential equation? The order for this differential equation is 1, because it contains the highest order derivative, which is 1, and the power for that highest order derivative is also 1. So order is 1, degree is also 1. The second equation in my write down is d square y by dx square. So that's plus dy by dx plus y equal to 0. So here the highest order derivative is 2. So the order is 2, and the power for that will be 1. So that's why it is the order is 1, degree is 2. The third one I may write down d square y by dx square plus dy by dx whole square plus y equal to 0. Here, whatever the power of this lowest degree is there, it's not affect the order and degree. Order and degree only involves with the highest order derivative and its power. So highest order derivative is 2. So that means order is 2 and the degree is 1. Let's go for the next example. 1 plus dy by dx is equal to y plus dy by dx whole cube. Now as you see the definition, so first of all the order is easy to recognize because it contains the highest order derivative is dy by dx, so order will be 1. So when we have to calculate the degree, then you have to find out what will be the degree of this dy by dx. So here the degree will be 1. On this side, since it is a cube, so that's why when you expand using the binomial expansion, the highest power, or you can say highest degree of the highest derivative will be 3. So that's why the degree of this differential equation is 3. So order is 1, degree is 3. Let's go for the next example. Let us write down in this manner. 1 plus dy by dx is equal to dy by dx plus sine x. So if you want to calculate the order for this, it involves the first order derivative. So that's why order is 1. So I am just writing here again order, and the degree that we need to calculate, because by definition of the degree, your equation is free from the roots, or I can say radicals. So you have to square first of all this equation. So that's why you can write down this as dy by dx is equal to dy by dx plus sine x whole square. So it is this, and hence when you expand this is by binomial expansion, the degree of this, or I can say power of dy by dx will be 2. So that's why the degree will be 2. So that is the order and the degree for this differential equation. Let's go for the next one. Let's say sine x upon dy by dx is equal to y square plus dy by dx whole square. So if this is the situation is there, Then also you can say that this involves the fraction. So the definition of the order is not effect because the order contains the highest order derivative, which is 1, and the degree that you can have by making this fraction as a simple equation, so that we can write down as sin x is equal to y square into dy by dx plus dy by dx whole cube. So that is the equation you will have. So that's why the highest order derivative here, it is dy by dx, and its power is 3. So that's why the degree will be 3 for this differential equation. Let's go for the next example. Let's write down the example like this: y plus x dy by dx whole power 3 by 2 is equal to x square sine of x into y plus dy by dx whole cube. Then what will be the degree for this differential equation and the order for this differential equation? Obviously the order will be 1 because it contains the dy by dx only. To find out the degree, so we have order will be 1. The degree that we need to calculate. So to calculate the degree, that you have to convert this equation free from this power. So for that, the root is there, so that's why it is 3 by 2 root. So I'm making the square both the side. So you can have this is y plus x dy by dx whole cube and is equal to x square sine x into y plus dy by dx whole power 6 is there. Now when you expand this side by binomial expansion, the highest power you will have 3, and on this side the highest power of dy by dx you will have a 6. So that's why degree of this differential equation is 6. So in that manner you can calculate the order and the degree of the differential equation. Let's give you one more example. Let's have this example: sine of dy by dx is equal to x square plus dy by dx. Now what will be the order and the degree of this differential equation? You just first note that the order of this differential equation is 1 due to it involves the highest order derivative as dy by dx, that is the first order derivative. But when you are trying to calculate the degree for the differential equation, as per the definition, it is free from these radicals and fractional. But what is the involved the sign of when you have the sign expansion, that is the sign series. When you have a sign series, you know that the sign series contains 1 minus x square by 2 plus x raised to 4 by 4 factorial and so on. This is the series of sin x is there. So when you expand the sine of dy by dx, it will involve this one, and since dy by dx is there, the power will be increased in that manner. So I can say that the degree for this differential equation is undefined. So that is the note I want to say about the order and the degree of the differential equation, which you already studied in your B.Sc class. Now let us go further. The next task, and which is very important, it says that the solution of the differential equation. So what does it mean of a solution of a differential equation? Because whenever the differential equation is there, everybody or in any differential equation is there, we are going to discuss its solution. So you should know what you mean by solution of the differential equation. A solution of the differential equation is the relation between the variable which satisfy the given differential equation and which is free from the derivative. Yes, I am repeating again the definition. A solution of the differential equation is a relation between variable which satisfies the given differential equation and which is free from the derivatives. So for example, if I have an equation dy by dx is equal to 0, then what will be the solution? Will be satisfying the relation of y, which is the variable, and the independent variable and the dependent variable, which satisfies this equation and which is free from the derivative. So here it is obvious that y is constant. Any constant will satisfy this equation. So that's why we can say that the y equal to the constant is a solution for this differential equation. In particular, I can say that y is equal to 2 is a particular solution for this equation, or in any constant you can put instead of 2, it will be the particular solution. For example, again if I can say dy by dx is equal to 2y, the solution for this differential equation will be y is equal to c into e power 2x. That you can verify by taking the derivative of this equation. This will gives you dy by dx will be again 2 into c e power 2x, because the derivative of e power 2x is e power 2x into 2, so that's I have written here, and c into e power 2x will be y, so dy by dx is equal to 2y. So that's why this is the solution for this differential equation. In the same manner, let's have one more example. Let's say y is equal to a cos x plus b sin x is the solution for this differential equation, that is d square y by dx square plus y equal to 0. That you can verify yourself. I am giving you as a homework to do that. So verify that. So what is the problem I am giving you? Verify that this is the solution of this equation. That you can take it as a homework. Now let us understand what you mean by linear differential equation. Linear ordinary differential equation I am going to discuss here. A linear differential equation is a differential equation, first of all, which is the independent variable and its derivative is not multiplied together. A linear differential equation is the differential equation in which the dependent variable and its derivative are not multiplied together and they are of degree 1. An ordinary differential equation which is of the degree 1. In fact, not on all the derivatives also having the degree 1, and they are not in the multiple together. For example, I can give you example of a linear ordinary differential equation. Dy by dx is plus y equal to 0. So that is the linear differential equation, I can say. Say for example, d square y by dx square plus 2 times dy by dx plus y equal to 0. So this is also one of the example of a linear differential equation, but I cannot say this is the linear differential equation. D cube y by dx cube into d square y by dx square plus dy by dx equal to 0. So this is not the linear differential equation. I may also say that y into dy by dx plus sin x equal to 0. This is also not a linear differential equation, but this is the linear differential equation, dy by dx plus y equal to sin x. This is the linear equation. This is the meaning of linear ordinary differential equation. So we have seen that the solution for the differential equation. Now the next topic that we have is the formation of differential equation. So let's have one of the example, and then rest of the things you can do it yourself. So the question is, find the differential equation for y is equal to a e power 2x plus b e power 3x by eliminating this arbitrary constant. Why they are called arbitrary constants? Because you can allow to choose any value of a and b. Let's say a is equal to 2, b equal to 3, then is also a solution for some differential equation. So that's why they are known as arbitrary constants. Okay, here our objective is to calculate the differential equation out of this. So you need to find out what will be the differential equation, which for that this is the solution. So for that I need to differentiate this equation with respect to x. So that will gives you dy by dx is equal to a into e power 2x, because the derivative of e power 2x is e power 2x and the 2 is there because the derivative of 2x is 2, plus b into e power 3x, the derivative of e power 3x is e power 3x and derivative of 3x will be 3. So that will gives you this. Again, if I differentiate this, the same equation, then we'll have it as 2 into 2, 4a e power 2x plus 9 e power 3x. Why I have taken the second time differential equation. There is one theorem, it says that if the solution contains two arbitrary constants, then the order of the differential equation must be 2 if it is a linear differential equation. Okay, so that is the things that we have keep in mind. And now we will have, this is the second order derivative. So we need to now eliminate this a and b from this three equations, that is the first equation, second equation and the third equation. So from this three equation we need to find out one differential equation which does not involve this a and b. We multiply the equation 1 by 2 and subtracting from 2 what we will get. So if you multiply this equation by 2, so you will have 2 here, you will have 2 here. So that 2 into a e power x is cancel out from this and you will left with this quantity, that is this will be 2 times y. So you have 2 here, 2 times y minus dy by dx. So this is 3b minus 2b. 2b minus 3b will be minus b e power 3x you will get. Now what we will do in the next step, we will multiply the equation 1 by now 4 and subtracting from the 3. What we will get is 4y minus b square y by dx square equal to is 4 minus 9, so it is 5b e power 3x, so it is minus 5 b e power 3x. Now from this two equations, the first equation that we got in the previous slide is 2y minus dy by dx, so it is 2y minus dy by dx is equal to minus b e power 3x. Now if I multiply this is by 5 and add these two equations, then what we will get, this will gives you, here it will be subtraction is there, this will convert into plus sign and this is also convert into plus sign. So this is minus, this will be plus, this will be plus. So this is 10y minus 4, so that will gives you minus 6y. This will gives you plus 5 dy by dx and this will gives you minus d square y by dx square equal to 0 on this side. So this is the differential equation that we are looking for, we will get. So this is the formation for the differential equation is there. There are other differential equation of such types I have given you in my lecture notes. You can go and try to solve that examples. First of all, we have discussed about the differential equation. There is a two classification of differential equation, ordinary and partial. We are only discussing about the ordinary differential equation on this course. We have also discussed that the order of the differential equation, the degree of the differential equation, a solution for the differential equation, what do you mean by solution of the differential equation, what is the linear differential equation, we have seen that, and then lastly we have seen how to format a differential equation. So all sort of things we have discussed into this lecture. Thank you very much for watching this video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in the comment box below. See you in next video. Till then, bye bye. Sayonara.